Okay, the thought on this problem is you got this projectile here that's going to go a certain trajectory and have a certain delta x, which is this usual parabolic looking thing I'll try to draw. And then you've got this friend here who's trying to run and catch the ball. So let's take the projectile part of it first. In this case, what I'm going to do is I'm actually going to use the range equation, even though I could break this into x and y components and find delta x just as easily. It's easier now that we have the range equation to just do that. So if you'd rather use the traditional approach, feel free. I'm just going to use the range equation. And so there it is, delta x equals VO squared sine 2 theta over g. So we don't have to resolve this. VO, that number 19 meters per second, that's what we want to put in for VO. Theta is 35 degrees, so 35 times 2 would be sine of 70 degrees. And we all know what 9.8 g is, which is 9.8. So we can solve that pretty quickly. If you just plug in all those numbers, you should pretty quickly get delta x. So that comes out to 34.6 meters. So that's the range of the projectile. So I won't draw that, but that's this delta x. That's from here to here. Actually, I will draw it. So there's delta x from there to there, and the friend has to run that same distance. So the question is, we need to deal with time now. So now that I know the delta x, I can just look at the x dimension and figure out how much time we're talking about to throw this path. So I won't draw it, but the x component, as usual, is this little part here. That's going to be VO cosine of 35. And VO we know is 19. We plug that in there. 19 times cosine of 35 is 15.56. And that's in meters per second. So then I just need to set that equal to delta x over delta t. And I could actually use the y direction to find time, but this is just easier since we just have constant motion. So I set that equal to delta x over delta t. That's supposed to be a t. And then I just plug this in for delta x, and that very quickly tells me how long this ball is going to be flying through the air. And that comes out to 2.22 seconds. Now, what about my friend? What I know about my friend is he's going just directly horizontally in the x direction at 5.5 meters per second at a constant velocity. So that's pretty easy to deal with. So he's going 5.5 meters per second in the x direction. Now he has to go the same delta x as the ball if he wants to catch it. So the ball is going to land 34.6 meters from where I throw it, so that his delta x has to be 34.6. So if I plug 34.6 here and solve in for his time comes out to, I get 6.3 or 6.29 seconds. That's how long it's going to take him to run that same distance. It's taking me 2.22 seconds to throw the football that same distance. So to catch it, he needs a little leeway, right? So the difference between 6.29 seconds and 2.22 seconds is the answer. That's how much ahead of time he should start running before I throw the ball.